Today we are going to be solving systems of equations by graphing. You have graphed before, so now all we're going to do is change it up and find the solution. It says consider the system y equals negative 2x plus 3 and y equals 1/2 x minus 2. This is a system of equations because we've got two equations with two variables. One is x and one is y. It says for each equation make a table of ordered pairs and then graph each line. I don't care how you do this. Remember, one option is that we can put those equations into our calculator. So we would go to y equals, and then we could type in the first equation, negative 2x plus 3. And then remember, it's table. See up there we're in blue, so we could go second table. And then we could actually pick the values from here. So 0, 3, 1, 1, 2, negative 1, so on and so forth. So we can write those down. Negative 3, 4, negative 5. Okay. And then we go back into y equals, and now we're going to change this. Again, remember when we put a fraction in the calculator, we have to use parentheses. So 1 divided by 2, and we put in our x, and then minus 2, not negative, minus. Hit graph. We could look at the picture if we wanted to. More importantly, we want to look at the table. So this time it's 0, negative 2. 1, negative 1.5, 2, negative 1, 3, negative 0.5, and 4, 0. Now we need to go ahead and graph. I'm going to use the equations to graph. Please feel free to plot the points if you would like to. So according to this, we're supposed to start at B. So I'm going to go up 1, 2, 3. And put my first point. My slope from there is negative 2, so I go down 2, right 1, down 2, right 1, and we keep that same pattern until we run out of places. And then you can use whatever straight edge you might have to draw your line. I don't happen to have one on me right now. So there's our line. For this one, we've got negative 2 is where we start. So I go down here to negative 2. And then our slope is 1/2. So we go up 1, right 2. So up 1 over 2. Notice there's already a point there. Up 1 over 2. Up 1 over 2. And then again, we can go ahead and draw our line to the best of our abilities. So it says for each question, make a table of ordered pairs, which we did. Here they are. Then graph each line, which we did. Now it says which ordered pair appears in both tables. Well, if we look, you should see that 2, negative 1 is here and here. So we would say 2, negative 1. It says, what do we call this point in terms of the system? So if we're talking about this, okay, the system of equations, we're going to call this point the solution. Then it says, what do we call this point in terms of the graph? Well, in terms of the graph, this point would be where this line and this line intersect. So it would be the intersection point. Now these are one and the same. The intersection and the solution are the same thing. They're both 2, negative 1. So to sum it up, it says, this is important, when the equations in a system can be blank, then the blank to the system can be described using the blank of the blank and blank. Okay? So when the equations in a system can be graphed, then the solution to the system can be described using the intersection of the lines I guess those would be on or of the graph. Okay, so again, the solution and the intersection are the same thing. So then it says y. Well, this is what we did the other day. If I take the original equation, y equals negative 2x plus 3, and I plug in my point. So remember, our solution was 2, negative 1. This is x, this is y. So if I plug in negative 1 equals negative 2 times x is 2 from over here, plus 3, and then I put that in my calculator, we would say negative 2 times 2 plus 3, and it equals negative 1. So I get negative 1 equals negative 1. The solution works for this equation. Well, remember we said for it to be the solution, it has to work in both. So let's plug it into the other one. Y equals 1/2 x minus 2. So I'm still plugging in negative 1 for y. And then 1/2 of x over here is 2 minus 2. So now I'm going to do the same thing I did before. Parentheses, again, fractions always go in parentheses. 1/2 times 2 minus 2, and I get negative 1. So negative 1 equals negative 1. So y, the point slash solution, works, and we'll put that in quotes, it checks out in both equations. So that being the case, that's why we can use graphing to solve systems of equations. So at the bottom it says use the slope and intercept of each linear equation to generate points or graphs, and then state the solution to the system. So let's graph. Let me fold this real fast. All right, so the first one, we're going to go ahead and graph. Remember, this is where we start. So we're going to start up at 2, so 0, 1, 2. And then our slope is 3 over 2, so we're going to go up 3 over 2. Up 1, 2, 3 over 2. And then if we wanted to continue, we could go down 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. And when you're trying to find the solution or the intersection point, it's going to be to your benefit to graph as many points as possible. So now we're going to look at the second equation. Remember, again, this is where we start, and it's always going to be on the y-axis. So we go to negative 1 and we put our point. This time my slope is 3, so I'm going to go up 3, and then remember this is over 1. So we go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. So we already found the intersection. Up 1, 2, 3 over 1. So if we've already found the intersection, then we don't have to graph any more points. So there's what our line looks like. Remember, the solution is the intersection. So all I have to do is find the ordered pair for the intersection. So here it is. If I go over 1, 2, so on the x-axis it's 2, and then up 1, 2, 3, 4, 5. So the intersection 2, 5 would be the solution to this system of equations. So if I were to plug this in for x and this in for y into these equations, it would work. So let's try number 2. Again, we're going to start here, and again, we always start on the y-axis. So I'm going to go up to 7, and my slope is negative 2 over 3. So I'm going to go down 2, right 1, 2, 3, down 2, right 1, 2, 3, down 2, right 1, 2, 3, and then we could go up to left 1, 2, 3 if we needed to. Then this one is negative 3, so we're going to go down 1, 2, 3 and start here. And then remember, this is the same as 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, keep going until I finally found that intersection point. So your job is to find this answer and show it to me. And once you've completed that and written it down, I will give you your assignment. Have a good day, guys.